Hi, this is our part two of our transformation lecture. I know the board looks kind of wild, but let's take one piece at a time. Now, the parent graph is the one that I had to give you in part one, and I just want to put it back over here just to remind you this is what we're going to be using for our transformations. So everyone's going to be the parabola shaped. So even part three, part four, the ones that are coming later, they're all going to be parabolas. Now, remember on your MyMathLab or whatever, they could be cubic functions, but I'm just going to stay consistent with one graph. So, because I'm going to teach you the transformations, not the shapes themselves. That was 3.4 that you learned all the different shapes. Actually, or maybe 3.2 as well. So, but anyway, remember there were 6 transformations and vertical shifts and horizontal shifts were 2 of them. So this is the vertical shift example. This is the horizontal shift example. And I showed you by a little definition when you're going to have a vertical shift. Vertical shift is when you have a function like the parabola, and then we call it the parent function. Again, the book will call it like the basic graph or the basic shape. Um, G of x equals f of x plus c will shift f of x c units up if c is greater than 0, and c units down if it's less than 0. So not put an absolute value because to make you understand that it has to be positive because you're talking about distance. So I gave you a couple of examples, g of x and h of x. G of x is x squared plus 3 and h of x equals x squared minus 3. So if you can tell the difference between g of x and the h of x is just one's adding 3 and one of them is subtracting 3. And I put it in green to show you that how the transform graph looks compared to the basic shape or the parent function. So f of x, which is x squared, remember this is the x squared graph. If you have x squared plus 3, that will take the graph and move it 3 units up. So you take this black graph and go 1, 2, 3. So point by point, this point goes to here. This point right here at 1, 1 will go up to 1, 4 because you're adding 3 basically to every y coordinate. So in essence, what you're doing is you're taking the black graph and you're shifting up 3 units. So that's when c is positive. So if this was x squared plus 5, you take the basic graph and just go up 5 units. So it's just taking the graph, cut it, paste it 5 units above where it's at. This is not a distorted graph. It's exactly the same shape as what it was before. All it is just a photocopy of the original. And you just move it 5 units up. And the h of x is x squared minus 3. And what it does, it will take this graph, the basic graph, and move it 3 units down. Same shape, not distorted, it just moves it 3 units down. So if you notice, this was a negative 3. So if this was a negative 7, you take the black graph and you move it down 7 units. So this is a vertical shift, up or down. Up if it's positive, down if it's negative. Okay? That's a vertical shift. Now the horizontal shift is that f of x be a parent function. G of x equals f of x plus c. Now notice the difference between this f of x plus c and this one. This c is on the outside, and what it's doing is it's being added or subtracted to the y coordinate. This one here is going to be added subtracted to the x coordinate. So what that does, it makes the graph go left and right. So anyway, so you have a g of x equals f of x plus c will shift f of x c units to the left if c is positive. And if in an absolute value of c, to guarantee it's positive, c units to the right if c is less than 0. So if you look at this one here, f of x, that's still our parent graph. I'm just reminding you what that is. Now this time g of x is x plus 4 squared. And what that's going to do is going to take this graph and move it 4 units to the left. So this is plus 4, which means it's positive, so it will go to the left. So you take this graph, 1, 2, 3, 4. Take this point right here, go 1, 2, 3, 4, and it's just point by point, not a distorted graph. It's the same shape, photocopying everything. So take this graph and move it 4 units to the left. Now notice this one, it's x minus 4 squared. And so what that one's going to do is going to move it 4 units to the right. So because it's negative 4. So you take this graph and take this point, go 4 units to the right, this point, go 4 units, so instead of 1, 1, it's going to be 5, 1. So this right here is negative 1, 1 will be positive 3, 1. So because you're adding 4 units to the x coordinate of every one of the points. So this one's a horizontal shift, so it goes left to right. This one here goes up and down. So right here, Now, understand, you can have a vertical shift and a horizontal shift all in the same problem. You could have, let's call it P of x. P of x equals x plus 4 squared minus 3. So you could have a minus 3 on the outside of this. So basically what this is, it's a double transformation graph. It's going to take the graph and move it 4 units to the left, and this minus 3 will move this graph 3 units down from where it's at. So it'll go left, then down. So it'll be somewhere down here in the third quadrant down here. So it'll go 4 units to the left and 3 down. And you can play musical chairs with every one of these. You could have x minus 4 squared plus 3. So if you have x minus 4 squared plus 3, it's going to take the graph and move it 4 units to the right. And what do you think? It's going to go up or down? Well, if it's plus 3, it's going to go up. So now it's going to be up in the first quadrant. So it'll be up in here somewhere. So that's the idea. So this is a vertical shift and a horizontal shift. So I showed you how you do them separately, but you can actually combine them. And this is just 2 transformations. Like I said a while ago, you can actually have multiple, more than 2. You could have 3 to 4 transformations all in the same problem. The only thing is, I got to teach you how to do the next transformations that are coming up. But this one's a vertical shift and a horizontal shift. Okay, so the next one's going to be reflections. I'm going to show you the vertical and the horizontal reflections. And now, again, those are not distortions. Those will be exactly the same shape. So that will be part 3.